All right, really important week this week. We are focusing on getting to free response questions. We'll get a 2 free response quiz here on Thursday. It's going to be like half of the points you need to pass the AP exam. We've got a graph of f and g is the antiderivative. So again, we've done this before. Sorry, I'm recording late. That's why I'm going a little fast. But this is g prime. We know that this is a start plus change equals end problem because we know the ending amount. We're trying to figure out what we're starting with. And then the other thing we can do is find the change in g. So to find the change in g, we integrate it from 0 to 3. Which of those things now can we find? Well, can we find this integral? How do I find the change in g? I integrate from 0 to 3. I'm finding the area under the curve. And so from 0 to 3, or 0 to 1, that's 3. That's 1.5. That's 0.5. Show me with your fingers. What is the change in g going to be? The change in g is going to be 4, because 3, 4.5 minus a half. This is 4 right here. What did we start with? Well, what plus 4 gets me 6? It's 2. That is my setup for this question. Questions there? The other way you could think of it is this. Okay? We know that g of x is equal to the antiderivative of g prime. We know what we're starting with, what we're ending with. If I took the antiderivative, okay, if I took the antiderivative, it'd be capital G of x, and you'd evaluate that thing from 0 to 3. So then you would find what is g of 3 minus g of 0, and we know what the thing's going to be equal to in the end. It's going to be equal to 4. That's the area under the curve. We knew this was 6 minus something gets me 4. It's 6 minus 2. You could look at it other ways. I like start plus change, but really all we're doing is the antiderivative and plugging in direct definite bounds. Questions there? All right. Today, we are going to make a foldable. Okay. Think about how many times this year that we've made a foldable. Think about all the different arts and crafts projects we've done. Know all those different arts and crafts projects we've done? No. We've done 0. And so if I'm making you do one, it's important. So know what you're doing here. All right. Real important day to figure out what's going on. All right. Here's what you're going to do. You're going to take your paper, and on your paper on one side, there are these big bold lines. You are folding your paper along those bold lines. So your paper should look like this in the end, where all you see on the back side is motion. Once you have folded on the bold lines, then you are going to cut the thin lines only. So it should make little flappy guys that flap over the different blanks. So your paper in the end is going to look like this. So when we look at this thing, okay, we're filling in each of these things. Most of these are words you already know. But again, we are doing a free response quiz on Thursday where you need all of these phrases. Okay, our first phrase is displacement. If we're talking displacement, what does displacement mean for us? The difference between the start and stop. Okay, when we're talking motion specifically, it's the change in position. It is the change in position. How do we find that mathematically? If we want to find the change in position, they're not going to give you position and ask you to find the change in position. That's too easy. Instead, they would tell you velocity. And to find that change in position, you integrate velocity from whatever your starting value is to your ending value. If you integrate velocity, that will tell you the change in position. If you start it in meters per second, when you integrate it, it's going to tell you the change in meters. That is different than total distance traveled. What do I need to do differently if I want to know the total distance traveled given velocity? The absolute value. Everything else is the same. We're integrating velocity. The difference is I don't care if I'm going forwards or backwards. I just care that I'm moving. So to do that, I need to take the absolute value of velocity. We would still do whatever our starting value is to our ending value, but that is how we are going to work along those lines. Okay, the absolute value of velocity integrated. So in our other flap on the other side, now we're going to do this based on a graph. So you've got a little graph on the middle of your paper. with your neighbor, I want you to find the displacement from 4 to 10 and the total distance traveled from 4 to 10. Figure out what those two values are based on that graph. Go. This is a velocity graph, V of t. We're looking at this. If we want to find displacement, here, I'm integrating from 4 to 10 V of t dt. Show me with your fingers, based off of that graph, what is your displacement going to be? Your displacement on this graph is 3. Okay, because to find the displacement, I'm finding the area under the curve. Well, that's 4, that's 5, that's 6. But what do I got to do with that 6? Subtract it, because I'm doing the change. And if it's below the x-axis, that's a negative. 4 plus 5 is 9, minus 6. The displacement is 3. That means the position change was 3 during that time interval. That is different than total distance traveled. If I'm doing total distance traveled, I'm integrating, still going from 4 to 10. I'm still integrating velocity, but what's the difference? Absolute value. Show me with your fingers. What is the total distance traveled of this guy? Now it should be 15. We are taking 4, 5, and 6. The only difference is I don't care that the 6 is below the x-axis. I'm just adding them together. 4 plus 5 plus 6 gets me 15, total distance traveled. Questions on the first flap? It's absolute value of all the areas. I don't care if they're positive or negative. It's all going to be positive for me. In theory, like when we graph this, it's basically taking that part that was below the graph and making it come to the top. Next chunk, change of direction. Okay, if you are trying to find the change of direction of your shape, or not your shape, of your object, when are you going to have a change of direction? What's going to happen? Velocity does what? Changes signs. It's most likely velocity is going to be 0, but velocity changes signs. It's not just equal to 0. It's got to change those signs. That's important. Okay. Technically, you could talk about position. S of t, I've seen this maybe once or twice ever on an AP exam. What would have to happen with a position graph for you to change signs? Talk with your neighbor. What would happen on a position graph for you to change signs, or for you to change direction? What do we think? What would happen on that position graph for you to change directions? Say again. S of t has to have relative extrema, has a max or a min. Because think about it. If velocity changes signs, velocity is the derivative of position. It's the slope of position. So I want the slope of position to change signs. That happens at maxes. The slope is going from positive to negative, or minimums, negative to positive. We don't see that very often. What about speed? What am I looking for if I want to know the speed of an object? Remember, in your car, it's called a speedometer, not a velocityometer. Absolute value of velocity. Okay? We don't care if you're driving your car, your speedometer says you're going 20 miles per hour, whether you're going forwards or backwards. We do the absolute value in order to get velocity, or in order to get speed there. Okay? Don't forget about that. Given S of t here. Okay, so position equation. Find when the particle changes directions. So they gave you S. They are asking you when the particle changes directions. What do you think you need to do first? Find the derivative. Go ahead and find V of t with your neighbor. It's been a minute since we found some derivatives. If I gave this to you on January 1st, it'd be super easy. Now your brain's going to play tricks on you. See what you can do. We are finding the derivative. Slade, what'd you get for your derivative here?
X to the third minus 9x squared
plus 27x minus 27. Good. Your brain could forget, and you're thinking about exponents. That's just something you got to be good at. You were really good at finding derivatives first semester. Just because we've thrown in integrals now, don't let that throw you off. That's what my derivative is. What do I want to know if I want to know when it changes directions? Set it equal to 0. And this would be pretty ugly. Okay, if you weren't thinking your way through this one, it would be pretty rough. The good news is this thing right here, and they wouldn't give this to you. I'm just being mean here. But that right there, if you factored it, would be t minus 3, or I'm sorry, x minus 3 cubed. Okay, so that is what you are trying to find equal to 0. It's a lot easier if it looks like that. We could solve for x. X is going to be 3, because 3 minus 3 gets you 0. We could then take it and put it on a velocity sign chart. We could throw 3 on there. Just because it's 0 doesn't mean it changes directions. We got to make sure it changes signs here. Okay, so we got to plug in a number bigger than 3. If I plugged in 4 here, it's positive. If I plugged in a number less than 3, like 1, 1 minus 3 is negative 2 cubed. Oh yeah, that's negative. So yes, when does it change directions? Boom, at x equals 3. Why? Because velocity changed signs. The next question, figure out when the speed is equal to 1. Figure out when the speed is equal to 1. Talk to your neighbor. Come up with a game plan to figure that out. Go. Show me with your fingers, what are your answers to this question? Dylan, what'd you do here to find your answers?
I set velocity equal to 1, and then just the equation.
Okay, so you set velocity equal to 1. So my velocity equation is this, x minus 3 cubed. If we set that equal to 1, that's not really finding speed. That's finding when velocity is 1. So what else did you have to do there?
I did the same with
With -1. Because he's figuring out, and think back to like algebra 2 when you solved absolute value equations. That's the equation he wants to know. When is the speed equal to 1? Absolute value takes away positives or negatives and always makes it positive. So if you want to do the opposite of absolute values, you split it up like this. X minus 3 cubed needs to be equal to 1, or x minus 3 cubed equals -1. That's the opposite of absolute value. It doesn't make everything positive. It could be either way. Then we solve. We cube both sides, so x minus 3 equals 1. You add 3, x is equal to 4. You cube both sides, x minus 3 is still equal to -1. And then you add 3, x is equal to 2. That is when my speed is 1 at 4 and 2. Questions there? Next one, speeding up versus slowing down. We just need to understand, what are we looking at to talk about speeding up or slowing down? What do I want to know about an equation to figure out speeding up or slowing down? Kind of. Be more specific than just slope. You need velocity and acceleration. Anytime we're talking about speeding up or slowing down, you need to look at velocity and acceleration. That has to be what's on your paper. If you don't say V of t and A of t on a speeding up, slowing down question, you're not getting the points. What needs to be true about V and t and A of t for you to be speeding up? Luke? Same signs. V of t and A of t need to have the same signs. That's how you could tell something's speeding up. And so obviously if it's slowing down, V of t and A of t have different signs. That is the key. You need to state what the velocity is and state what the acceleration is, and then based off of that, you can tell if something is speeding up or slowing down. Okay, so what I put here is a Punnett square kind of thing. Not truly a Punnett square, but that idea. So like velocity is positive, acceleration is positive. I would be speeding up. Finish the rest of that Punnett square. Nothing crazy there. You should be able to fill that in. You should have been able to fill that in probably like in September. Everybody go to that point. Let's draw a graph. I'm going to draw you a graph, and then based off of this graph, I want you to tell me when it's speeding up and slowing down. So let's go with this guy right here. Let's throw like 1, 2, 3, 4. 1, 2, 3, 4. We're going to make a velocity graph here. This is V of t. Let's do something like this. I was so close. Based off of that graph right there down below, figure out when are you speeding up and when you are slowing down. Talk with your neighbor, figure that out. We're doing speeding up versus slowing down. Aiden H, when would you say you're speeding up on this graph? 0 to 1 and 2 to 3. 0 to 1 is always the easier one because I'm getting further away from the x-axis. 2 to 3 is the harder one. But think about it. If you had a point on this, if this is a velocity graph right there at that dot, velocity is negative because I'm below the x-axis. Acceleration is negative because I have negative slope. I'm getting further away from 0. That is why I'm speeding up. Okay, so obviously I'm slowing down from 1 to 2 because from 1 to 2, like right there, velocity is positive, but my acceleration is negative because I have negative slope. I'm getting closer to 0. And then I'm also slowing down from 3 to 4. If you're looking at a graph, I think it's easier. Are you getting closer to 0, further away from 0? If you don't have a graph, that's when you need to make sure you're stating velocity and acceleration. Questions there? All right, let's get to the one that is the most missed out of any of these. Okay, the most missed is the idea of average value and average rate of change. Average rate of change is what we did back probably in August. Average rate of change. When you hear the phrase average rate of change, what do you think? Slope. Specifically, what kind of slope, though? Not instantaneous. A 2-point slope. Okay? It is a 2-point slope. Instantaneous slope, that would be a derivative. But this is a 2-point slope. When you take something like y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And here's what you got to get from this. You use average rate of change. You use this when you're trying to find the average of the thing below it. Okay, that seems kind of weird, but the average of the thing below it. So for example, if you have position and you want to find average velocity, find the slope. If you have velocity and you want to find acceleration, find the slope. The average rate of change tells you the layer below it, what the average is. That is different than average value. Average value is when you want to find the average of what is given. So for example, if you are given velocity and I'm asking you for average velocity, or I'm giving you the rate the water leaves the barrel, and they gave you the rate the water leaves the barrel. Okay, if that is true, that is when you're doing average value. Remember what average value looks like. That's when we're integrating from whatever your first value is. So like T1 to T2, your starting value to your ending value, however you want to call it. You integrate whatever is given. So V of T dt. And then what else do I have to do to find the average value? The fraction thing in front, the upper bound minus the lower bound. What would happen to your units if you're finding the average value? If you're doing this, what's going to happen to your units? So if you found if you put velocity in here as like meters per second, what would your units be when you finish? Meters per second. Because this thing in front is time. This tells you meters. This is over time, so it'd still be units per second. Units stay the same if you're doing that. If you're doing this one, the units add a time to the denominator. Because if you have position, if you find the slope, that is going to tell you velocity. So if it were meters, then it would become meters per second. We're not good at that. This is something we're going to have to understand, the difference between average rate of change and average value. We will continue to hit it the rest of the semester. Try those two. Okay, try those two problems down below with your neighbors, see what you can do. So again, this might be the most important thing we're doing today because this is the thing we struggle with. On the first one, they gave me position and asked for average velocity. So is that the same thing that they're asking for the average of it, or is it the derivative that they're asking for the average of? The derivative. And if I wanted to find a derivative, I would find the slope. So they are asking here for the average slope because I'm going down a layer. If I'm finding the average slope, that is the average rate of change. So to do that, I'm doing two ordered pairs, 1 and 3. I take 1, I plug it in, I get 0. I take 3, I plug it in, I get 26. All I need to do is then do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If this was measured in meters, then this top would be meters. That'd be like meters. And then 3 minus 1, that is your time. So that's where I'm getting 26 over 2. Oh, it's 13 meters per second. I added a unit to my denominator because I found the slope of it. Okay, I'm going down a layer when I find the average rate of change. Makes sense on the first one. Second one, they are starting with velocity. They gave me the thing that they are asking me to find the average of. They gave me velocity, and they want me to find average velocity. Well, to do that, if I'm finding the average of what is given, I'm finding the average value. I'm going to integrate this thing from 1 to 3. I'm going to integrate whatever my equation is, which in this case is 3t squared. In front, I've got to include the fraction of 3 minus 1, so it's 1/2. And you can do this. You can do it by hand. Add 1 to my exponent. Divide by my new exponent. I'm evaluating that thing from 1 to 3. So I plug in 3. And you got to take that whole thing and multiply it by 1/2. 3 cubed is 27. Minus 1 is 26. And then it's 26 over 2, otherwise known as 13. Again, this right here would tell me meters, because when I integrate velocity, it's going to tell me the displacement. That's the meters. That's 27 minus 1 meters. But this 1 over 2 in front is seconds. That is why my units are still going to be meters per second. Velocity would tell me meters per second, and when I find the average of it, it's going to stay meters per second. That's really important as to what we're doing. Questions on how we did this thing? Obviously, we made it a foldable for a reason, so you could go back and revisit it and see what you're doing. Okay? Here's what you got for tomorrow. On